Welcome to the BoF. Since it's a BoF, I didn't prepare much because I already was speaking about the recent work yesterday. So I just prepared a couple of slides with the review. So this is LTO and profile feedback related stuff which got into the GCC 15. So I think one of the bigger changes was the incremental LTO, which was implemented by Michal. We had this partitioning for locality, which was one of the late additions because of me, because I was very slow on reviewing the patch. There was quite few work which was related to optimizing memory allocations and also getting them optimized inter-procedurally. And we got this new unsequenced and reproducible attributes, which I still don't exactly know how they should be handled correctly. So that might be one of the topics to discuss. And there was a lot of changes related to libc to the C++ containers, which the other things are also related to. Basically, the idea is that I would like GCC to be able to optimize stupid code, like creating empty string and not using it. And this is surprisingly hard to do, but we are able to optimize out empty strings by now. And yeah, the libc is using a lot of built-in unreachable calls to declare various invariants to GCC, which is helping to optimize these containers, but it's also confusing IPA code, so that improved, but it's still not perfect. And Jakub Jelinek implemented the top-level ISM syntax, which we also might want to discuss today. So the GCC 15 has the front-end changes. There is no support for partitioning, which is something that needs to come. So this is the situation with trunk. Yesterday I was speaking with AutoFDO, which is something I hoped I will do in the week. I'm doing it for 3 months at least by now. And so it's, I think, getting closer to be useful, but it still needs some work. There is kind of noticeable change about cloning hot functions which are not called by hot call, because there was a mistake in the heuristics for years. So as a consequence, the IPCP is much more busy in the main line than it is on the release branches. And that means that it also runs out of the allowed growth of the program. So like for DeepSync, it's really producing 30% extra code for no speed up, which is interesting. We got profile maintenance improvements, which was necessary for AutoFDO. We got the speculative demonetization for multiple targets, which is very easy patch, but it would be nice to get it used. We got I increased the partitioning count, which was also easy change, but it's thanks to the kind of incremental improvements to streaming. So like already in GCC 15, the one-to-one streaming is quite useful, which was not the case of earlier GCCs, because the streaming was not very linear. It was bringing too much of context into every partition. So that has improved noticeably. On the other hand, I think we are on the end of increasing the partition counts if we don't change the VPA stage, because at the moment, if you have 12 CPUs, the local transformation stage is finished in no time, but the VPA is taking most of the time because it's not parallelized. We got ISM partitioning by Michal, so that's the beginning of the kernel support, which was discussed yesterday too. And we got the OpenMP for offline kernels, which I think is, I will approve the rest of the patch like tomorrow or tonight, or yeah.
For this topic, I think we should discuss here what to do with the attributes.
Yeah.
Later on.
Yeah, I think that's one of the topics which, yeah, I think it's a good idea. So there is a pretty big list of things which I think should be merged to the trunk, and they are in the various stages of work in progress. So there are patches for locality improvements. There is a vectorization profile update patches where I lost track, and I think they are not completely merged, and they should be. There's some streaming improvements, like we don't stream the value ranges, which was noticed like by Jakub a year ago. So that needs to be finished, and we need to do the plumbing on the ICF side. There is a patch for speculative virtualization of the calls which are done in the C way using function pointers instead of virtual calls. And there is kind of increasing things which needs to be finished from the student work. There's a loop histogram support for profile feedback, which I think it is actually useful for vectorization because we know what to do with the prologues and epilogues. But yeah, it needs to be tuned and it needs to be cleaned up. There's a patch for bypassing the assembler for streaming LTO out of the compiler, so that should speed up the normal FLTO compilation. But it is still kind of work in progress, so it works to some degree, even with Dwarf, but only if you get lucky. So it needs someone to finish it. There is handling of the types for exception handling. So at the moment, if you throw an exception of the type integer and you catch it, the GCC will not notice that you caught all the exceptions which can be possibly thrown, and will believe that the function is throwing out because it will not understand the type. And so there are patches for that, which I also need to clean up. And there is also some work on doing more work in VPA, which might be useful. And there's a last slide. So those are the things which I think which are various stage of to do. So I guess that's one of the topics we can speak about if we run out of the topics. And I noticed that Jakub is already interested to discuss the attributes. So I guess we can start with that and move to other things.
Yeah.
So initially, Josef wrote the patch based on the attribute which LLVM has, and the problem is that it's defined weirdly. It behaves differently from other attributes. It's a function attribute where you specify it has a callback, and the callback has this argument. But normally, when we in GCC we have attributes which like non-null, where we specify this argument behaves like this. We don't count this, I think, and so on. And I think in this, and so the attribute in Clang, you either specify an index, but it has to be an integer, not for instance a constant expression or something which is weird. And in that case, it's in index, but counting it differently from all the other attributes. Or you can specify the argument by name, and again it has to be an identifier, and it's kind of like in the OpenMP case where the attribute or OpenMP pragma comes before the names of the attribute. So you need to take the tokens, remember them, and then when you know the argument names, you apply them. So the question is, do we implement the attribute as specified in LLVM? Do we implement the same attribute name but with a different syntax? For instance, of course, the problem is if it would be always just the Clang scope callback or whatever the name of the attribute is, that would be fine. We could just not implement it. But the problem is that in the GNU attribute syntax, we don't have the scopes, and therefore they just implement it. The callback is like the LLVM in that case. Or we can use a different name for the attribute. Mm-hmm. So what's the preference? Because I think such an attribute is really useful so that it's not limited just to the OpenMP stuff, because people have callbacks in many cases, and it allows really to propagate stuff to the callback where you guarantee that the callback is the only place called from this function, and so that you can propagate constant into the callback.
So so I think easy to think of example is a quicksort function So the quicksort function is taking the callback and then it is passing some parameters to it. And yeah, so we need to way to describe this behavior. So the GCC can rewrite the callback by a different function. If it understands, it can propagate some facts. Yeah, just to make a short summary what it does.
So I would suggest to implement the attribute with a different name in a same way, specify it, and when we end up needing compatibility, just try to translate the Clang attribute into a GCC one.
Yeah. So yeah, I also agree. I think if we have GNU callback and LVM callback, it would be confusing because I would read it only as a callback, and I would be surprised that it has a different semantics. So yeah, I think the full story is that with Josef we invented the attribute, and only later he noticed that it already existed in LVM. So it's kind of a logical concept and logical name for it, and it's already taken, which is annoying. But maybe some callback only or calls callback was something I was thinking of. Yeah. Because it's not only callback, it's also promising that the function doesn't do anything else with the pointer, like compare it to function, or it only can do to call it as a callback, not hide it somewhere or something.
Or leak it into global state.
Exactly, yeah. So I think callback only is a more specific name of what it is. Josef, do you have some preferences?
It's really difficult because the attribute in LVM, it does have the same semantics, like exactly the same semantics, but the syntax differs when it comes to this pointer. So like, what should we do? Because initially what I thought, that maybe I was being a bit naive, that maybe we could fix it in LVM and...
They won't change it.
Yeah, the full part of the story is LVM is supporting the callback attribute, but it's not using it. So the backend part is not implemented.
Yeah.
As far as I know.
So why even add it?
They have it, and that's already taken, right?
And the problem is usually they don't document what
Yeah.
they add.
Yeah.
Yeah, the thing is, the state of the attribute in LVM is really unclear because it is merged and has been merged for what I think is now 6 or 7 years. But when I tested it to verify the claims made at conferences like Euro LLVM, I couldn't verify anything. I couldn't get it to work. So it's present in the compiler, but it doesn't seem to do anything. So
Yeah, I think it's sort of common situation with LVM that things are present but disabled by default. And I don't think this has a way to enable it. So I think the original author didn't help with that either, right?
Sorry, are we done with the attribute, or are we still discussing this? No, since you brought up the locality partition, I thought I could also give an update on there because we continue working on that. So now that that's landed is 15, so thanks for the thanks for the approval.
Yeah. So maybe just to summarize the callback thing. So if someone doesn't get a better idea, I would suggest to call it callback only, just to have a different name and go ahead with the meaningful definition of the indexes. And it would be nice to also support the names, but
definitely done separately from the rest of the patches.
Yeah. So incrementally.
The most important part will be the documentation, what it currently is, and then we can start using.
Yeah. Okay, so sorry for interrupting, but yeah, I just wanted to be sure that I understand. Okay.
So about locality partitioning, we won't keep developing it. So the version that landed is 15 works okay, does a good job for our workloads with instrumented PGO, but instrument PGO is not really deployable in that case in production because the overheads and the stuff you discussed yesterday. So what we really want is make it work with auto FDO. So that's where a lot of the effort we have in GC16 is fixing that. Some of that is kind of blocked on generic auto FDO issues like the zero profile stuff, messing up the profile and things. But those are getting better. We have a few more. Prathamesh in our team is working on improving some things and adding a few extra kind of mechanisms for experiment with it. So we have some example patches that will allow you to specify your own kind of order for GCC to use, so we can order it. That's it helps more with kind of debugging all of these decisions. But what we want to get to in GC16 is to have the path to these ordering decisions based on AutoFDO data. So I think we're quite close there, and we have some patches that will be going out soon. Then Prachi, who wrote the actual original code there, also send out some patches to improve the algorithms to make them reduce the complexity and cache things a bit better. So those are, I think, in reviews that should improve the performance of the pass. They should be visible in Bootstrap when you bootstrap with that pass enabled. And the other big thing we're working on is trying to add some heuristics that work statically, so without any feedback information, so only during LTO. That's probably going to be a very tough one to get generally, but for some workloads, we talked about AI workloads earlier today, so these kind of workloads we're talking about. We saw they have some patterns where they have like C++ templates that end up getting expanded get expanded in many different ways, and keeping those together seems to help locality. So that's the kind of thing that could be determined statically. So that's the other thing we're exploring.
Yeah, so there are a couple of things which I always was planning, like, when I started to work on IPA, which was 22 years ago, this was one of the things which I wanted to implement soon, right? Basically, I think, there are multiple kind of granularities of this. So like the way the GCC works today is that we run the light optimization in the order, so the code functions come before the calling functions. And the reason is that we want to propagate simple effects like inter-procedural register allocation. So, if we compile the function, we know what registers are clobbered, and we can save some pushes and pops load and stores on ARM in the later function. And this is not a good order for CPU. The CPU would prefer to execute like going down, right? My plan was always to use the gas fragments. Output the things in the order which we need to make the RTL backend work, and then let the assembler to order things correctly. That's one thing to do. And then the LTO came, and we do partitioning. So the partitioning is implemented in the way that there is the order index in the declarations, and we are basically packeting things in the blocks according to the order, which was afterthought. Originally I wanted to do it differently, but then I found that this works pretty well, and it's still there. And we are getting kind of increasing pressure on how the partitioning should work. Like Michal has the cached VPA, so you want to sort of keep the partitions local to certain source files. We have the Linux kernel, which has ASM statements, which might or might not like to be in the same partition. So we will have this forced partitioning. So overall, I think the order of the functions in the final binary should not really depend on how the program is partitioned. We should have a way to put them into numbered sections, which will be ordered by a linker eventually. So yeah, those are the things which I always wanted to get working, but I never got to. So if we work a little bit that direction, that would be great. Okay, there is a...
Sorry, to add to that, I agree that currently the way LTrans objects are sort of laid out is not really what we want in the final linked version. And to that extent, I was also looking at this linker doing the final layout as part of the static heuristics, because that is where you really want the difference to show. Static heuristics are hard anyways, but with the added layout constraints that we have currently on LTrans, it's doubly difficult. So I was sort of adding that linker provided order support as part of that.
Yeah,
so
yeah, that would be very nice.
I will also upload
So
that
how do you
part.
interface the order to the linker?
So what I initially did was so the IPA locality pass, the way it works right now is it determines the order. I'm just saving that order in a variable that cgraph then carries on to the final pass, where I just dump that order into the linker script, and then that is carried
so
on.
every function is its own section, and the
Yes,
linker script is being generated.
So all of it is in a sorted section, one section. You just dictate the order, and then so basically in the sorted section you have the indices.
Yeah, that's. Does it work with different linkers? Like we have malt and.
Yeah, we'll have to
salt?
check. Not reached that part yet, but
because that always stopped me from doing it because I
Yeah.
was lazy to learn how gold works.
yes.
So yeah.
Yeah.
That would be very nice if this worked.
So I can post the patch, and we can sort of currently I have that as part of the static heuristics, but I can just take it out, have a separate discussion on it that can go independently, and then the static heuristics can sort of flow into that. So that's where really I'm at.
Yeah, and that's also something which I think I put it somewhere on the slide, but I'm not sure. If we get it working, we should get it tested. So do you have some proposal how to benchmark it regularly? Because we have this LNT which is able to run various benchmarks. So we can add specific benchmarks for code layout, or we can measure it somehow.
Yes, so anything that is not spec and really big as a benchmark is a good candidate. So we can probably have a discussion on
what to choose.
which ones are. So for example, Redis or MySQL, for example, these are sort of bigger benchmarks which are not synthetic, that may be sort of the targets.
Because internally I'm doing kind of testing with building LVM because it's huge, and building Firefox. One of the problems with these things is that they tend to break all the time. So if you don't watch it, some C++ extension changes, or so we need to pick up projects which are kind of friendly to future.
I think Firefox and
in good
LLVM
C++,
are good
which is very hard to
targets.
find.
Yes, exactly. Not GCC though. So, but LLVM and Firefox do sound like good.
Yeah, the
targets.
Firefox is more difficult. LVM is pretty reliable, but it also has its quirks. It used to be crashing with or aliasing because it had the bugs they was refusing to fix. Now they implement aliasing too, so they fixed it. Okay, so that would be nice.
The bootstrap tester be good, or is that not something that?
You might have better data than I do. My experience with this is like from many years ago, because Martin Liška, actually, he was my master degree student, and one thing which we worked on was this ordering, and we ended up with kind of implementing this time profiling. So with FDO, we simply measure the time of the execution of the function, and then we order in the time. And for me, that was kind of initial experiment, and I thought it will be stupid and it will not work very well, but it turned out to be working pretty well, and we still do it. And then Martin actually implemented this kind of clustering algorithm, taking call edges, taking them in the priority order, and packing them together in the right sequence. And I was never able to measure the patch to be beneficial on Firefox or on GCC. Okay. So that's why it never got to mainline. And so so if you are able to measure something on Bootstrap, I would be very happy to brief you and start testing it. I wasn't back then, but it was a different. It's many years ago, like at least 15 years ago. 10 years ago.
So Bootstrap is good for catching obvious functional errors and some of the performance errors, but GCC is kind of not big enough for the kind of perf testing we are talking about. So adding a bootstrap test is needed, but that is not the only kind of testing we can do.
Yeah.
Yep.
So Firefox still has, it has this benchmark which is called TP50, and what it does, it's loading like 50 most popular pages and measuring the rendering time, and that's pretty good test because it's executing a lot of random nonsense in the binary, and they have the additional benchmark which is basically simulating a scrolling, and then it's waiting how long it takes the Firefox to get into the waiting loop. And that's something which was highly sensitive to the code layout. Like you could get 20% improvements very easily. So something like that
would be a very good benchmark to test this on.
But
Yes.
my problem is that I was never able to run this benchmark reliably myself. So what I did, I was using their testing setup, which somehow magically worked. We cannot abuse Mozilla's infrastructure on this.
Correct me if I'm wrong, but does Firefox build clean with GC these days, or did they kind of migrate to client?
It still builds.
Okay.
They use it for fusing. From time to time, I have the account there, which I can access this benchmarking servers. So this year I didn't do it yet, but last year and every year I sort of get it working. I verify that it works. One of the problems is that Firefox is switching to Rust relatively aggressively in the internal data structures. So that means that because we cannot compile the Rust part, it's becoming less relevant benchmark for us. If we get Rust, it might be again very interesting. So switching to Chrome might be a good move, but I know nothing about benchmarking Chrome. I tried LibreOffice and I thought it's a very poor benchmark. It does simple stuff like walking linked list, transferring UTF-8 to UTF-16, or So finding a good benchmarks would be amazing.
So any benchmark where you have a lot of libraries in play and a server client or a driver and then invoking various other libraries, any type of benchmark that utilizes that, so Firefox and any other stuff, is probably a good enough starting point, and then we can go from there and discuss more.
I don't know much about databases, but I think those might be reasonable. The MySQL or So if someone tells me how to do it, I will be happy to try.
Yeah.
Yeah. Okay. So I don't know. We have some more thoughts about locality. I think after the BoF we can sit and look on the patches. So I can understand what's going on. Yeah. So the other topics which I think might make sense to discuss would be this top-level ISM support, so the current situation is that Jakub was nice enough to add the syntax, but it's not plumbed into the symbol tables, so the renaming doesn't work. So I think the general idea is that Michal has added support for the ISM statements to actually appear in the symbol table as sort of object. The problem is that I think the symbol table should contain symbols, right? And the ISM statement is not a symbol. It's kind of the blob of something. But the important thing is that it has references to symbols, and these needs to be renamed. So I think what we need to do is
not just references, but also could have definitions.
Yeah, exactly. Yeah,
have multiple definitions.
Yeah, that's what I wanted to discuss a bit. So at the moment, the symbol table is organized in the way that there are symbols, and we have some understanding that one symbol can be part of the other symbol. It's a little bit broken in the way that the real symbols in the object file, they are just locations, right? They don't contain bodies. The bodies are like a sequence of the blobs, and the symbols are pointers inside. For us, in the symbol table, like function together with the body is the object, and then the aliases are sort of referring to them. And the IPA code understands that if it puts somewhere the function, it also should put there the aliases. So I think, yeah, we can have the ISM statement, and then we can have somehow the symbols, which are referring to be part of the ISM statement.
Yeah, because the
And-
ASM doesn't have to contain a definition,
Exactly.
then it should be taken as an unnamed
Yeah.
symbol, probably with aliases to it being the definitions and references.
Yeah. So that's why I was a little bit sitting and waiting what I should do about it. So so I think Michal's patch, which is by kind of adding the common base between the symbol table and ASM statements. So the references can refer to objects which which are not symbols. And then I think each of the symbols which are defined in the ASM statement should be just separate entries of the symbol table, which know that they are defined inside of this unnamed blob of something. And
But the first step is we need to stream it actually, stream out, which I try to and couldn't.
yeah, no, the streaming part I can
the
add.
streaming of the normal top level ASMs is just streaming the string and that's
Yeah, exactly. And we need to add this. So that's
I do have a quick work in progress page that actually does the streaming, and for now it only does the all those reference symbols. It uses the same code as the heuristics, so it just takes the data from the external assembly and it currently works.
So if I defined the symbols, do I know which symbols are what type? Because for our symbol table, we have functions and we have variables. We have nothing else, which is broken. Like there are also labels which are in the symbol table and we don't understand it. That's where they break with partitioning. But if I define the symbol in the ASM statement, do I know if I'm defining what kind of symbol I'm defining, or is it just a symbol?
Because the ASM.
The colon argument is an address of something, and the reason why it's an address is because normally if you put the function name, you get the function pointer anyway, and therefore you can find out if it's a function or
okay. So I have a normal
variable.
Declaration.
You need to have a declaration.
I know it's defined in the
And also from whether the declaration is static or global, you can find out is it
and can
local
I
or
define a named label in the ASM statement or only functions and variables?
well, if it's a named label, you declare it as a function, I think.
Okay, so then
because we don't have a construct in C where you have an alternate entry point, or in Fortran you have, but. So I would call these a functions and variables. It's also it can be a constant something or
because we also technically eventually should support alternative entry points to functions, which we just don't because we are lazy. And that's just kind of the same phenomenon. Like you want to have another function symbol which knows that it's part of outer things. So I think that's okay to implement.
But it's still kind of an alias connected to the main entry point. For the streaming, I think the first test is to use a top level as ASM without any references to anything else, but just constants and stuff like that, and just try that it streams out and through the LTO.
Basically, we will do it with Michal, I guess. Basically, you want to follow, how the variable initializers are streamed. And then, instead of streaming variable initializer, you stream the ASM text and all the references to trees which are inside.
Yeah.
That's not hard to implement. It's just a little bit unhandy API for that, I guess.
It's not Gimple, so so you need to.
But it's the same about the global initializers.
Exactly.
So it's a very similar object.
Yeah, so in that context, we also have the constant pool entries, which we eventually want to represent, like the string constants. Have constackers for them.
So that's sort of historical problem because at the beginning I implemented call graph because I wanted to implement in liner, and then it became a symbol table. So it has this call graph and var pool, which are the kind of bad names. I think it should be function symbol and variable symbol, and maybe we want to rename it at some point. And so I think we also should have the label symbol and have the labels, and with the constant pool, I think it's also variable. So it fits there. The main problem is that the current infrastructure for constant pool and for labels doesn't let you to export the symbol from the object file. And as soon as they become part of the symbol table, they get partitioned, they need to be exported. And that needs to be implemented on every target, which is annoying.
You can also
Mangling for that in that case.
Yeah. Well, if you have, for example, inline function which has taking address of a local label, the label is sitting in one partition and the address can be taken from other partition. So it has this kind of numbered name which local labels has, and we need to invent a name, but the mendling doesn't need to be stable. It's going to be the LTO pref thing.
So for constant pool, we can just duplicate the constant and rely on the linker constant merging. So we don't have to invent
I think there was
export
bugs with that, because if you take the address of the string, you want it to be the same.
Yeah. So in that case,
Yeah.
if we need to unify for correctness,
But you don't, the standard doesn't guarantee that.
No, but if it wasn't the same translation unit, it does guarantee.
Yeah, exactly. So
And
we have a
that's
bug about that.
happening right now, it's not working with sanitizer or undefined or address.
Even in the same translation,
Yes.
if it's used multiple times, if you type the same string multiple times, it's not guaranteed.
No, not guaranteed. It's a
But in
very
this
long-standing.
case- in
Yeah.
the case
The same
that-
one.
In the case that I'm thinking of, it's the same one, it screws up.
Yeah. We screw up for many years, and no one really is punching me. So but there's a long time.
the issue is, of course, that we have this address of string constant in the IL itself instead of address of the constant pool of the constacle.
So adding the constant pool into the symbol table is easy, but this plumbing, I think it's going to be scary, because the constant pools goes by very specific ways through the all backends, and they will need to be updated. So that's the part which always scared me.
Yeah, with the anchors and whatever.
So the specific one happens quite a bit with standard regex with LTO. We've gotten at least 3 reports, I think, for the same thing. So.
So if someone volunteers to rewrite a constant pool, I would be very happy. The IPA part I can do, but having the way to export symbols, it's important. It can be implemented, which is just not there. We have some more on this. So, I don't know what else we should we want to speak about. I think I have quite a few things which are related to IPA propagation and cloning. So maybe Martin would like to say something. So I think that kind of it's just he's just here.
But where to start? I think that there are currently many issues. One is that once we found out the bottleneck, IPA CP is doing lots of work which means that it switches itself off before doing often the useful things. So I do have a patch which basically does the decision stage in multiple sweeps throughout the call graph, and just tries to do the things that are estimated the best first, and then it's slightly more lenient and slightly more lenient. It's how many times the sweeps or how many sweeps there are depends on a parameter. The idea is to have 3. We can have 4. So that's one thing that's probably going to land soon. The other 2 issues that I think we now have a test case for, basically X264, is cloning for value range propagation, which is something that we don't do. We just propagate the value range if it is the same for all callers or call contexts. which doesn't work if the function is, for example, if its address is taken. And so basically I'll need to be adding even more candidates for cloning. And the other thing that I also noticed is that even with constants, we just basically take the parameters from left to right, and we first look at the normal constants, and then we look at the constants in the aggregates or passed by reference. And we don't try to sort this or somehow try it with the best one. And that also means that we use the opportunities that are not useful, but actually like change how the call graph looks so that we cannot do the useful ones later. So that is another thing. And then the associated issue is that sometimes it's important to propagate values or value ranges into in two parameters. And so but I do not have a good idea how to do yet, but we did discuss it with Honza a little bit, is to sort of try to use the predicates to somehow come up with a good order, and what to try and what not, rather than just trying it extensively for just each opportunity or a pair of opportunities, which of course wouldn't scale. So I think that's my current thinking on this. As I said, the multiple sweeps through call graph, that's basically implemented. I fixed the last bug there a week ago. And but how to do the selection of candidates to include value ranges and do it in some better order, that will be interesting work.
Yeah, so I kind of find the heuristic to be sort of, sometimes it's extremely conservative. Like, if you have a function which contains a single indirect call and we prove that the call is going to be constant, it will clone. But if there are two calls, it will not clone anymore, which looks like we should do it. So I just noticed it because I broke a test suite by this multiple speculative the targets patch.
Yeah, I noticed that too. That looks like some kind of bug, or I don't know.
Yeah,
It was
so
like
the cost,
I was reading the description, like I need to have a look at that, but I didn't.
Yeah, so the cost computation is sort of magical, and it doesn't.
It was always intended as something to start with and then improve on later, but then we never, except for adding a hint for this and hint for that, and it's, but we need to get a lot of basically things and end up with a single number, and that's always going to be magical, I'm afraid.
Because if you look what the IPCP is doing, my experience is that it's doing a lot of cloning, which later is handled by inliner anyway, because the functions are small. When the functions are big, it's kind of afraid to do any cloning. So the number of, there are, of course, test cases where IPCP is very important, which is like Exchange and X264. But yeah.
Yeah. So with the inlining, I mean, it can still be beneficial when function A calls big function B, which passes a constant to function C, which is small but uses the constant in a meaningful way. Then we can even when we inline a clone, it's already a specialized clone, and we don't have to clone the function B. We don't have to sort of. So that's kind of. It can still be useful, but yes, basically it's not trying to do something that the inliner will do anyway is a difficult thing, because then the heuristics are plugged into cost computations which are used by both, and it's probably a reasonable thing to do to have it used for both of them to use it. But right, I need to run it, basically do this with the sweeping patch or multiple sweeps patch. I need to try various aggressiveness levels, well, on spec at least, and see what happens, and then start from that, which is That's something that I plan to do very soon, because now we found out that the X264 is very likely something that can benefit.
Yeah, and also, yeah, I think I put it on the slide. There's a kind of limitation of the IP prop, which is important for C++, because, for example, if you have the string, this std string, the way the std string is constructed is that there is a constructor, and the constructor is taking 2 pointers. To the beginning of the string, it is constructing from, and to the end, it doesn't take the length. And that means that we see it as 2 different parameters, and if the string is constructed from is, for example, sitting on the stack, we propagate nothing, because those are 2 different pointers to local object. So we completely lose the track that the string is short. That, of course, important, because if the string is short, then the destructor will not call delete, because the new call will never happen. So, we should inline constructor-destructor pairs for short strings, but maybe not for long strings. And because we are not able to track the size, we are lost. And I think this is a pretty common coding pattern in C++, that you have pointers of known offset, or at least known range.
All the ranges stuff.
Exactly. So that's something which we should be able to represent on the IPA level. Yeah, my thought was that maybe, when we see the parameters which are coming from the same base pointer, we should give the ID of the base, so the base is unknown to the propagator, but we know it's the same base, and then record the offsets. So that would sort of solve this. But then we need to be able to use it.
One will be positive, one.
Yeah, I don't know. This is the base plus 60, and this is the base plus 74. And then, when the callee function calculates minus of these 2 pointers, we will be able to determine it's a constant. That's my idea, but I don't know.
We could even do like IPA SRA and pass only the base and the actual offset and not 2 pointers.
Yeah.
Or it can be just a range. It's 0 to...
Yeah.
Because
Yeah,
I mean, it might happen that we know the value range of the difference.
Yeah, the problem
not
is that
only
IPS array has a cost, right? You have to duplicate the function, and if you have like std string, you are better to use the official function, because it's somewhere in the binary, and you can merge it by comdat. So I think, I think IPS array is a good idea too. I didn't think of it, but I think we need both anyway. We need to be able to optimize uncloned function bodies.
So yeah, look at the jump functions. That's definitely something that's would be useful addition. But another plan for jump function is to rewrite them in a way that they look similar to the predicates actually, because the predicates also originally did not have any of the arithmetic component, but I think it was Feng Shu or someone, it was done for the exchange, that they basically added the ability to encode almost arbitrary like binary unary operations there before the comparison is then like evaluated. And we should just use the same for the jump functions. That would basically allow us to not just parameter plus 3, but parameter times 2 plus 3. Plus, we would get rid of the ancestor function, which was probably a mistake. And
yeah, we also need to.
But it then means it will be more general, and things like hacks like these might be a little bit more difficult to implement. But we need to find out.
Fit into memory, because the jump functions are big. That's the other problem. But
are they really much bigger than the predicates?
I will generate the statistics again, but I remember they are kind of substantial in the...
Because I was afraid always of having it, but then I realized, well, if it doesn't matter for the predicates, then...
We can measure it, I have this Clark LTO built, so I can just make the statistics.
Put them into some
5 minutes.
allocator pool or something, try to make them compact.
Yeah, we also need to extend the predicates, because the predicates are able to explain the conditions like argument number 4 is less than 16, but we need to be able to know the argument number 4 minus argument number 7 is less than 16. So we need to be able to store 2 numbers instead of 1, so we need to revisit that too.
Like references to 2 parameters rather than, and that might be a major surgery actually, and make it a little bit less similar to what we want to do with jump functions.
So we have 10 minutes, so maybe 7 minutes. If there are things.
I just wanted to ask a question. What are possibilities for, let's say, target-specific IPA optimizations? So, for example, on AR64 with SV intrinsics, we have a lot of SIMD intrinsics that take a SIMD predicate that masks off some lanes. And we recently added quite a lot of backend folding code to fold these. So if you have like all false predicate and all true predicates, sometimes you can, simplify those intrinsics. But some people in our team had an idea that maybe if we could kind of propagate this, this predicate information across different functions, because you have one function that creates a predicate, and that's used in all kinds of callees in IPA, where we could, add more intrinsic simplifications.
Okay,
But
maybe I didn't think of it.
it's just
yet.
simply implementation churn, or do we have any kind of
Yeah.
design reasons not to do target-specific information?
Just doing VRP over vectors to do what you want, what you need.
I guess if those predicates are represented as, a real chemical construct rather than opaque target-specific thing.
Yeah, I think I didn't think of target-specific IPA at all, to be honest. I think there are like two things. Like, we can add a new pass. We have infrastructure for that, so you can implement your own IPA pass and just run it. I will be scared of it, but I will probably, you can convince me. But the other thing is that this sounds like another object to propagate for. And also you might want to do cloning, and we might to do all the other things which we do. So that means that there might be a way how to add target-specific info into IPA prop and make IPCP to live with that, which we never considered something like that. So that might be good to discuss what exactly you need and how it looks like with Martin. Yeah.
Yeah, I would suggest to create some artificial test case and put open a Bugzilla for that, for tracking. Because I'm also curious how it actually looks like.
For the function splitting, I was wondering if we couldn't do something like the if conversion does with the separate original scalar and a copy of the loop, if he couldn't do something like that for the function splitting, because I think it's very common that you either inline back the part into the original function, or that you inline both the inline part and the rest as well, and it always screws up debug info and stuff like that. So if we could basically copy the body and create a new call graph and create the connection that this is the split, these are the two split parts of this function, and then the inliner could decide, am I going to inline back the body into it, then use this body, or am I going to inline both again, and then of course throw away whatever we don't use.
Yeah, no, to be honest, the way the IPA split works is that I wanted to have something to experiment with. It was not meant to be like that for 10 years, but it happened. The problem, you basically have two options. Either, to produce all the split parts greedily before IPA, and then they live as real functions in the IPA pass, and then the IPA decides to put it back together because it makes sense. The other option is to somehow, just decide that the cloning is possible and keep it record it in the symbol table.
That would be an option as well, sure.
Yeah, the problem is that then you need to update all these analyzers of the other passes, like compute jump functions for the fake clone, estimate the size of the body of the fake clone. And that's an extra complexity which needs to be implemented.
Yeah, but so if you create it as a separate CGraph, then
well, you still need to analyze. You still need to analyze the body.
You would
which
need
you
to
don't
analyze
have.
both and just decide.
Okay, so you want to keep the original function and you want to keep the split functions.
So basically,
and have both.
Three graphs instead of two.
Yeah, but you want to create also three different bodies greedily and then throw away two of them, or
Yes. Well, right now you'd create two of them, and
then
so
merge them back together. Yeah, yeah.
You would create three. Yeah.
Yeah.
Because I think it's really very common, and it would help debugging, because then users are really surprised why
I have a part in the
it's the original function, and just it got messed up.
I guess so. Yeah. It will have overhead because you will have to stream more, and you will have to. But yeah, the splitting, and also the thing is, I put
or
it.
We could do it only for smaller functions.
Yeah. No, I put it there because one of the offlining which we don't and we could do is, at the moment we only split when the function has the common header, like lookup in the cache, and most of the time item is in the cache, and then the tail is closed, like it doesn't go. So what we can also offline are the single entry, single exit regions, which Clang is doing. Clang is able to offline parts of the function which they do for a kind of what's called partitioning. And there are test cases where doing this makes the outer function to be inlineable. So it's also interesting. It's something we don't. And then you have the situation that you have the single function and offline 5 different regions. And then all the 5 possible combinations can happen as they get back together. So we are preparing bodies for all, 2 power 5 options is expensive. So that might be problematic too.
Yeah.
I don't know. Yeah, it's.
But definitely outlining a part of the function.
Putting it back
is useful, especially for very high register pressure.
Yeah, exactly. Yeah.
Maybe we can, instead of producing the actual body, put in some kind of internal functions at the boundaries and have the multiple entry symbols,
and then all the analyzers will have to support it. Yeah, that's what I was thinking of.
Yeah,
I'm sort of afraid of it because we will have to do calculate the jump functions, which is already difficult, and so we will need to think of nice APIs for that.
So if you have the multiple entry points and virtual exit points, it would be just C-graph nodes where you have the jump function computation should be hopefully transparent, that the IL isn't really in separate functions, but
yeah. So we will need to have some kind of function region API and be able to handle those
function fragments somehow.
Yeah.
Which
would be also useful, to do.
Normal function splitting is also creating the partial is similar.
Yeah, but it's a specific one. So what it does, it finds the edge, which is breaking the control flow graph into the header, and the tail must go to the return. So there's no, we will not offline the situation when there is a body. And there's an example which you looked into recently. There's a function which is looking on the global variable. If it's null, it calls allocation, and then it returns the global variable. And we don't split it because what we see, we see the load of the global variable at the end of the function, which is not constant, which is not copy propagated yet. That's the common part which prevents splitting because it's not just the return block; it's something more. So this is the example of offlining the region instead of offlining a tail of the function. And we don't do that. And if we will do it, that makes sense to offline multiple regions from single function, which would be interesting.
Yeah, it's also when we have kind of the fragments, its interest would be maybe interesting for vectorization, that we can do per loop ISA selection, like other compilers could do in the past. I'm not sure if LLVM can do that, switch the ISA between loops.
If
which
we
is
get
also
some
something we can't do.
support,
We can only do that if we offload, outline a loop, and then use the target attribute thing.
Because historically, the IPA split, I think, is older than the offlining for OpenMP, or it's about the same time. So at that time, I was sort of experimenting with what can I do. The implementation is not optimal. It's also limited that there's no way to propagate something from the header to the tail. So if the header loads a global variable which is used in the tail as the copy propagated value, we will not split because we see there's a SSA name surviving the boundary and we just give up.
Yeah, we could in theory tail duplicate.
We need to basically make the closure like lambdas. So we still have a time. Stop. Okay. So yeah. So thank you, and the rest, we can speak offline. So thank you.